Hey there! Let's talk about rational expressions. So, these two are the basic ones, not the real complicated, just one denominator and two monomials. And the first thing we need to do is use the exponent properties, such as 1 over x equals x to the negative 1 power. Same concept here is that we need to subtract common like terms, like variables. So x to the second power, we need to move that to combine it with x to the fifth power in the denominator. So what we can do is divide it. So x squared, we can cross this out, and just leave it with x to the third power. Same thing with y. Instead of y here, 3 minus 1, which is 2. So we're just combining it to simplify. And also here, 8 and 12, just like a regular fraction, 8 over 12, you can reduce it by dividing by 4, is 2 over 3. So 2 and 3. So let's write this a little neater. 2 over 3x to the third, y to the second. Alright, next one. A little bit more complicated, but really the same concept. So 2x plus 4 divided by x squared minus 4. So the first thing you see is that, oh, it's already simplified because I can't cross anything out. Actually, that's incorrect, because we can actually still factor or take a distribution. So for right here, we know that both terms have 2 in common. So we can take out the 2 as the GCF, as so. And for the denominator, it's actually the difference of squares. So this would be x and 2, and as we know as the formula, x squared minus y squared equals x plus y and x minus y. So we can do the same thing here. And luckily, we do have something that can be simplified, or crossed out, if you will. And we can cross out these two since they are the same thing. And our final answer is 2 over x minus 2. Let's take it a step up from the one denominator expressions. Here now we have two denominators, and they're different. So like what you've learned with fractions, you have to make them have the same denominator. So we have to find the LCM, the least common multiple of both of them. Right here, we have x minus 2 and 3. Off the top of your head, you don't really know what are the common multiples of x minus 2 and 3, so normally you just multiply them together. So the LCM of here would be probably 3 and times negative 2, x minus 2. What we need to do to make the denominators the same is multiply both sides to complete the denominator. So we multiply this by 3, and over here by x minus 2. And if you change the denominator, you have to change the numerator. So let's get started. 3x minus 3 over 3x minus 2 plus x squared minus 2x over 3x minus 2. Now that the denominators are the same, we can combine the two fractions and get x squared plus x minus 3 over 3x minus 6. Now for our next one, it gets even harder, but if you really look at it, it's just like the second problem in the previous page. All you have to do is factor it first to get the overall look of actually what the denominators are. So right here, x squared minus 16 is another one of those difference of squares. So we can get x plus 4 and x minus 4. To make the denominators the same, you have to multiply this side by x plus 4. And we don't need to get two x minus 4s by multiplying all of them, just get the least common multiple. So here, the least common multiple would be x plus 4 and x minus 4. Alright, let's multiply this side by x plus 4. So here, we're going to multiply the whole side by x plus 4. X plus 4 times 2x minus 6 divided by x squared minus 16, which is just here, plus 3x squared minus 10 over x squared minus 16. Let's simplify this before we go on by using FOIL. So 2x squared minus 6x plus 8x minus 24. And the middle would be 2x. Alright, so let's finish this off. 2x squared plus 2x minus 24 divided by x squared minus 16. That's it for rational expressions. Thank you for watching, and this has been provided by SATFreePractice.com.